This video covers all the stories we talked about this week in the Daily Space Science Shorts. There are aurora, biosignatures of life on an exoplanet, new experiments on the ISS, spectacular new JWST images of the Crystal Ball Nebula, and the missing river deltas on Saturn's moon, Titan. Hope you enjoy the edit and have a great weekend. If you love aurora, then heads up, because we might have some big activity incoming on April 16th. NOAA's Space Weather Prediction Center has a storm watch for the 16th following two big coronal mass ejections, or CMEs, from the Sun on April the 12th and 13th. Predicting the arrival of these massive clouds of charged particles is always tricky, but if they arrive together, they could generate significant auroral displays at much lower latitudes than normal. Of course, there's no guarantees, as aurora depend on many factors, such as the relative alignment of the magnetic field in the CME with the magnetic field of Earth, and a bunch of other things, but at least the ingredients are there. We just have to wait and see if the auroral cake is fabulous or a flop. SpaceWeatherLive.com is a great place to check auroral forecasts. As you can see from this screenshot, the forecast for April 16th is for KP7, where the KP index measures global geomagnetic activity as measured from the ground, and KP7 could see aurora as far south as Denver in the US or Paris in France. Check out the most detailed image ever taken of planetary nebula NGC 5414. Needless to say, this was taken by the James Webb Space Telescope. This JWST image of the nebula, also known as the Crystal Ball Nebula, really brings out the dusty rings, and it's thought that the two bright stars in the center of the image help form this nebula, which is why we see this double ring structure. Don't forget, planetary nebulae actually don't have anything to do with planets. They're the remnants of a dying star that has shed most of its atmosphere into space, and then the remaining hot, luminous core of the star ionizes all the ejected gas and gives us these spectacular objects. Planetary nebulae are formed by stars from about 1 to 8 solar masses and only last a few tens of thousands of years, so their lives are brief compared to the lifetime of the Sun that could be about 10 billion years. The Wikipedia page for planetary nebula is really good and clears up the misnaming. If you're wondering what the NGC and NGC 1514 stands for, it's an abbreviation of New General Catalogue of Nebulae and Clusters of Stars. It was compiled in 1888 by John Dreyer and contains 7,840 objects, including galaxies, star clusters, and emission nebulae. Astronomers use a bunch of these different catalogues to identify objects, and it's quite common for the same object to be listed in multiple catalogues. For example, the Pinwheel Galaxy is listed as Messier 101, but also NGC 5457, UGC 8981, PGC 50063, and ARP 26. Dreyer himself published 2 supplements to the NGC called the Index Catalogues, and those contain another 5,386 objects. That's probably more than you ever wanted to know about astronomical catalogues, but at least the next time you see an NGC or an IC number, you'll have a rough idea of what's going on. A SpaceX mission will launch April 21st to resupply the International Space Station. Amongst the crew's supplies will be 2 cool science experiments. First up is ESA's Atomic Clock Ensemble in Space. The goal of ACES is to compare a highly accurate clock in space with atomic clocks on the ground, including some provided by NASA, to check Einstein's general theory of relativity. GR says that how we experience the passage of time is influenced by gravity, but there are suspicions that GR may not be a complete theory, and scientists are hoping to uncover any small discrepancies over the 30 months of the experiment. The experiment should help us improve our precision timekeeping in space to assist with navigation and communication. The other experiment is the Advanced Plant Experiment 12, or APEX 12. This will study the idea that inducing telomerase activity in plants can protect their DNA from the damage caused by the stresses of life in space. If you're going on a long space trip, having a hardy crop of plants on board that won't die easily will be key, and the research could also have applications to therapies for age-related diseases in humans on Earth. You can find more information on both of these experiments over at the NASA website. There's a bit of controversy around today's story, and the drama is unfolding around the star K2-18, a red dwarf that is cooler and smaller than the Sun and located just 124 light-years away from Earth. The planet at the center of the story is K2-18b, a type of planet known as a sub-Neptune. It's about 2.6 times the radius of Earth and almost 9 times as massive, and orbits its star in just 33 days. Previous observations of the planet have discovered water in the atmosphere and then carbon dioxide and methane. There are a couple of interpretations of this data, and that's partially what some of the discussion is about. The planet could be a gas-rich mini-Neptune, or it could be a Hycean planet, that is, a planet with a liquid ocean and a hydrogen-rich atmosphere. The authors of the new paper claim that their data confirms a Hycean planet and that they have detected dimethyl sulfide and possibly dimethyl disulfide in the atmosphere of K2-18b. The paper claims that the only way for DMS and DDMS to be produced is through the presence of organic life, although experiments in labs on Earth have been able to produce DMS without life being involved. The detections are also statistically quite weak, and the scientists say they need an additional 24 hours or so of data to confirm their findings at the 5 sigma level, which is typically the level of statistical significance required for a result to be considered concrete in the scientific world. I'm sure there's lots more to come on this story, and if it does end up being confirmed, it would be quite strong evidence for the presence of biological life on the planet, although I'm sure the arguments will continue to rage. You can find the paper over at the Astrophysical Journal Letters, and I'll include a link in the description. Did you know Saturn has 274 confirmed moons? The largest of these moons is Titan, which turns out to be a lot like Earth. It has an atmosphere, clouds, wind, rain, and liquid rivers and oceans on its surface. Instead of liquid water, though, Titan has methane and ethane flowing over its surface, which are both liquids at Titan's surface temperature of around minus 180 Celsius. To study the geological history of Titan, scientists were hoping to examine its river deltas. These can provide a wealth of information as they gather sediment in one place that can reveal a lot about the history of a planet. That's one reason NASA's Perseverance rover is studying the ancient river delta at Jezero Crater. Titan has surprised scientists, though, because it doesn't seem to have river deltas. NASA's Cassini mission imaged Titan when it flew past in 2006 and showed channels and large flat areas thought to be large bodies of liquid. What it didn't show was the expected river deltas. So did Cassini's synthetic aperture radar instrument just miss the delta features, or are they really not there? To answer that question, scientists built a model of Earth, replacing its water oceans with methane and ethane, and then they simulated scanning it with Cassini's synthetic aperture radar. What they found was that Cassini would clearly have found the large river deltas that almost every river on Earth has where it empties into the ocean. That seems to imply that there really are very few deltas on Titan, and researchers have suggested that maybe winds and currents along the coast move sediment, or perhaps the sea level rises and falls so rapidly that deltas don't have time to form. There are some other strange geologic features in the Cassini data of Titan, and it's an interesting area for further research to dig deeper and explore these mysteries.